Hi friends, a very good evening and thank you for joining in today. Could you please confirm if you're able to see the screen that I have, and also can you confirm if you can hear me clearly? Again, I'm in a slightly different location from where I stream every day, so you might experience slightly different audio quality. So can you please confirm uh, the can you please confirm about both the audio as well as the video stream of my laptop? Okay, all clear. That's good to know. Again, somebody is asking what is the next subject. Surely, that I was just about to announce that once CD is over, we'll start whole of mathematics, both engineering and discrete mathematics. Anyway, we'll announce the exact topics because the syllabus for both engineering and discrete math is vast. So we will break it up into chunks. It could take us about 2 weeks or maybe even more. And we'll try to solve a bunch of problems. Again, engineering and discrete math sessions also will be open for everyone. Okay, so yeah, so our team is also putting it up there. Thanks to the mentors and rest of the team. So we'll be doing graph theory, propositional logic, and group theory first. Again, we'll announce videos for that. Again, it'll all be engineering and discrete maths. We'll break it up into chunks and we'll announce for every session what would it be. Okay, sounds good. Okay, sounds good. So let's wait for a couple of minutes for everyone to join in. Then we'll go into the session itself. Again, I have some high-level overview about compiler design. We'll discuss this as soon as we start the session. So somebody is asking, as a computer science graduate, should I choose the GATE course, the interview prep course, or the applied AI course? It's a choice that you have to make. We strongly recommend that you pick one of them and put in your full efforts into it. Of course, it is possible if you have time on your hand, it is possible to do both GATE and interview prep course simultaneously, because all of programming, data structures and algorithms, there is an overlap, and the problem solving skills that you build in one will always help in the other course. So please think through it. It's a choice you have to make, whether you want to prepare for GATE or for AI or for product based interviews. It's a choice you have to make, but whatever you make, you have to commit to it fully. Don't keep shifting from one to other. That's very important. So what if someone didn't yet finish watching the video lectures for the next math sessions? That's perfectly okay, Afra. It's perfectly okay if you have not watched them. We will add these videos to the course itself at the end of each subject, so that when you're studying that subject, if you have not prepared that subject, it's perfectly okay. Just go back to that subject. We'll keep adding all these problem solving sessions to the course videos itself, so that when you arrive to that specific point, you can start tackling these problems, right? So don't worry about it. Okay, yeah, so we have our team also responding, which is good. Again, Shubham asks, by when should you complete your GATE syllabus? Again, we have seen people who completed their GATE syllabus in August, and we have seen people who completed their GATE syllabus even in November, right? So it all depends on how thoroughly you have completed, how much practice you have done for each subject, but try to complete it by early November. The earlier the better, because you'll get more time, but don't jump. Whenever you're doing a topic, please try to do the topic or the subject as thoroughly as possible. Practice as many problems as we have in the course. Don't skip the practice. We see a lot of students who skip the practice. I've been mentioning this in every session. Please don't, please don't skip the practice problems, right? So please do the problems, and if you can finish it anytime before early November, because you'll have November, December, Jan, and maybe a week or so in Feb. So 3 months is more than sufficient to revise it a few times, right? But earlier you can finish, the better, always. So notes, yeah, we have the notes available on our website, right? So just go to gate.appliedcourse.com. Let me just show you that. Just go to gate.appliedcourse.com, and if you go to these blogs, you will have the complete notes for the GATE CS subjects. So just go to GATE CS blogs and click on complete notes. You will get the notes for each of our subjects, right? Along with links to free videos. if you're not a registered student. So these are publicly available. Please make the most of them. Try to use it for your own revision, even if you're not a course registered student. Okay, cool. So Nitin says, I've started my preparation from June and I'm doing my job. It's okay, Nitin. As I've mentioned in the previous live sessions, try to spend 3 to 4 hours every day. Fix a time. I've also mentioned how to be disciplined with your preparation. Either fix in the morning or evening, or 1.5 hour in the morning or 1.5 hour in the evening. Try to complete the whole syllabus by late October or early November. While you're doing the job, I completely respect it. There are a lot of people who prepare for GATE while doing the job. If you're disciplined with your efforts, you can comfortably finish the jobs. You can comfortably finish both your work at the job and also GATE syllabus. That's not something that you need to worry about. Okay, my stream is stable. Okay, sounds good. It's already 7:02, so let's get started with the compiler design problem solving. Again, my team will try to answer some of the questions in the chat window, which I may not be able to answer because I also need to progress through these questions, right? So let's get a quick overview of the whole compiler design. You can expect a minimum of 3 marks, but anywhere from 3 to 5 marks in a GATE exam from compiler design. Again, along with TOC, it is one of the easiest subjects to score in GATE. And thankfully, there is a lot of overlap with concepts from TOC, whether it is most of your compiler design is all about context-free grammars. Of course, there are other topics like lexical analysis, intermediate code generation, etc., and semantic analysis, etc. But most of it, there is, especially in GATE, a lot of questions will have overlap with TOC, right? So if you learn both these subjects together, you can comfortably get a good chunk of marks. Again, very importantly, please avoid silly mistakes. While the questions are easy, people try to give questions where you'll fall into the silly mistakes trap. Again, some problems could be time taking, right? There will be some problems even today which will be time taking, but they're simple to solve. You don't have to, if you know the method, while they're slightly time taking, if you know the method and if you've practiced enough problems, you can solve them quite fast, and the time that you're spending is worth the 2 marks that you will get. So lengthy problems in compiler design typically are about 2 marks. Okay. So from next week, we'll start a very big and major subject, which is both engineering and discrete mathematics, right? So we might require 2 or maybe even 3 weeks for whole of engineering and discrete mathematics. Again, it's a very, very scoring subject with a lot of weightage. So we'll start announcing what topics we'll cover on daily basis or on weekly basis. So please stay tuned to our channel. And all the sessions in engineering and discrete maths also will be publicly available. So the first round of all the subjects, we are trying to keep them open so that everybody benefits. As many of you have been asking about the GATE 2021 test series, we have launched it on Sunday, and we have about 2,225 questions as part of a 2021 test series. And you can just go to gate.appliedcourse.com and find more about test series. Again, today I don't want to spend much on the test series because we've already launched a video with all the details. Please check it on our YouTube channel. Any questions you have, feel free to reach out to us. We'll try to answer as many as possible. Okay, so let's get to the questions, right? So first question, let's tackle this. Once sufficient number of students respond with the answer, I'll explain the answer. These are very simple questions, so please think through it carefully. This is an easy question. Again, most compiler design questions are easy. Okay, I see a spectrum of answers here. 32, 34, 36, 29. Okay, let me see. Yeah, these are the 4 numbers that I see here. Think of it like a fill in the blank question. Again, we are also giving some easy questions so as not to discourage some students. Again, you can expect a question like this for about 1 mark in GATE. Okay. There are no options here, just fill in the blanks. Okay, since many of you have answered it, let me dive into the solution. It's a very simple thing. Look at this. The lexical analyzer, the very first phase of the compiler, it will think of this as one token, second token, third token. So in this line, there are 3 tokens. In this line, there is only 1 token. Remember that lexical analyzer completely ignores comments. Comments are something that the programmer writes for their benefit. So it will completely ignore this. Now let's look at this line now. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 tokens here. Okay, this is a typical C program. Similarly, what about this? 1, 2, 3, 4, 5. 5 tokens. Similarly here also 1, 2, 3, 4, 5. 5 tokens. Many people would have made this mistake. Again, this is a comment in C, so this will also be ignored. Now here is a slightly tricky thing where many people make mistakes. Okay, so here look at this. You have printf as 1 token. This whole thing is a string. Remember, this whole thing is a string, so it will be considered as 1 token. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 9 tokens here. So if you notice, what is the total sum? 3 plus 1 is 4, 4 plus 9 is 13, 13 plus, oh sorry, there is 1 here, I forgot, sorry, that's how we make mistakes, sorry, 4 plus 9 is 13, 13 plus 10 is there something that I've missed somewhere? So 3, 1, 9, 5, 5, oh there should be, 1 second, did I make a mistake somewhere? Let me start counting it again. I think I made a mistake somewhere here. Just let me do it. I think I made a mistake here. Just let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There should be 10 here. Yeah, in my notes I wrote it as 10, but when I was counting here I made a mistake. So if you just sum up all these numbers, this is 11, 20, 25, 25, 1 second, did I make some? 3, 1, 9, 5, there is also 5 here that I missed. Okay, so this is 11, 11 plus 9 is 20, 30, 34. Yeah, 34 is the answer. Yeah, here I forgot to count the open parentheses earlier. So again, these types of problems are very easy to make silly mistakes in, but if you're careful, you'll get it right. Okay, I almost made a silly mistake, right? See, I forgot to count this line once, I forgot this. So this is very, very prone to silly mistakes, but if you're careful, you can get the answer very easily, right? So in GATE, for compiler design, most questions are easy, but they'll be slightly tricky like this. Okay, so let's go to the next second question. Sorry, this is the second question, not the first question. Sorry, this is the second question. Okay. Again, a very simple question, but very prone to silly mistakes. Actually, you can just look at the 4 options and tell the answer in like 20 seconds after you read the question. It's that straightforward. It's a small thing that you'll make a mistake at very often. Okay, again, this is a very simple question and I see a lot of people getting it right. If you notice this, again, you can start deriving each of these strings from this grammar that we have using these production rules. The only key thing here is look at the dot at the end here. Remember that in this grammar or in these production rules, dot is also a terminal symbol, right? If you notice this, dot can never be at the end of a string. Dot has to be always between two IDs. Look at this, id dot name, and name itself can be replaced by id or with more id dot names, right? Address itself can be name at the rate name dot id, and name itself can be id or id dot name. So you can never have the dot at the end of the string, right? See, look at this. This can be generated. Again, you can simply try it, right? If you notice, the name itself can be an id, so this can be generated. Name and id. This name itself can be replaced with id. So if you just apply simple production rules here, you can generate A, B and C, but you cannot generate D because D has the dot at the end, and it's using these production rules. You can never have the terminal symbol dot as the last symbol in the whole, in any string that you generate. So D is the answer here. It's a very simple question. Very easy to get confused. Again, a lot of people just skim through it, don't notice this dot. Again, a lot of questions in compiler design and TOC are slightly tricky. They're not hard. If you do not read the question carefully, you'll miss it. Right? It's a very simple question, but tricky, and you have to be careful. Okay. So let's go to the third question now. Again, this is a big question, so I had to squeeze it on the screen. This might take a little bit of time, but it's an easy problem. If you know how to simplify a grammar, this is a very simple question. Okay, I see a few of you putting in your answers. Please verify your answers just to make sure that there are, because I see some of you putting an incorrect answer and intentionally it's been given with a little trickiness there. So some of you have made a mistake, so please cross check your answer. Sorry. I see a wide spectrum of answers, so please take 20 more seconds to correct if you have made a mistake. Okay, so let's actually go through the solution. Okay, so first and foremost, let's remove null productions, right? So you have A derives epsilon. So let's try to simplify this. So what can we write it as? S derives, wherever A is there, let's put an epsilon, right? So what would you get here? You get AA or ABB or just A epsilon, which makes it A. So first I'm doing the elimination of null productions, right? That's the first step, right? Again, it's a very simple step-by-step process that you can follow. Then you have A generates. So if you place epsilon here, what happens? You will have AAA, or because A generates epsilon, you can just say AA. If you place epsilon here, you'll get it. As far as B is concerned, nothing changes. BB or BBC. C generates B. Okay, so you've removed the null productions. Now try to eliminate unit productions. So let me draw that. So you're removing epsilon or null productions here. You're eliminating unit productions here. I'm just writing it here so that you can see it for yourself. So if you eliminate unit productions, what happens? Okay, again, it's a very simple thing. Okay, you have C generates B here, right, which is a unit production. Right, so unit production is nothing but X generates Y, where X and Y are variables. So what would we get here? So let's start writing this. AA or ABB or A. So this stays the same. A generates, this stays the same. Nothing changes here. Again, I'm writing it in step by step so that you can see the solution step by step. But in the examination, you can solve it much faster. Okay, BB, BBC, C generates B. So this is a unit production. So what can you do here? C generates, wherever you have B, so B generates this, so you can write it as BB or BBC. That's it. So unit productions have also been eliminated. Then all you have to do here is elimination of useless symbols. All the symbols that are useless, you remove them. Now here comes the tricky part where a lot of people make a mistake. So let me use a different color here. Okay, let me use this color here. If you notice here, this is very, very important. If you look at variables or non-terminals B and C, look at B and C. B and C never generate strings. Okay. See, look at this. B will start generating another variable B or C. Again, here C is a variable. Okay. So B will never generate a whole string of terminals. Similarly, C will never generate a whole string of terminals. Right. So if you notice, B and C will never be part of generating a string of only terminals, right? So B and C are useless symbols here. So if you remove them, what you are left with is just these two. C generates AAA or AA. So what is this equal to? This is same as D, right? So AA or A, AA or A, yeah. So this is equal to, right? It's that simple actually. So somebody says there is a buffering issue. Let me just check the streaming from my end. So streaming from my end is fairly stable. Steps carefully from any text of some sort. 1 second, let me just. Let's just wait for a second. I think the stream should become. Naveen, I'm looking into it. Okay. Guys, I'll just look into it. Just give me a second. I'll try to fix it by changing my Wi-Fi antennas. Is it better now? I just try to fix my Wi-Fi. Sorry, folks. Yeah, I had to travel for an emergency, so I'm not in Hyderabad at my residence where I have a much more stable connection. But let's see. Let's try to get this working. Okay, so now it's clear, right? So my stream is also stable now. Okay, if there is any problem, do let me know. I'll try to fix it. Okay. So this is where I was. Okay. So if there is any problem, just let me know in the comment section. I'll try to fix it. Okay. So the audio is clear. I hope the video also will become stable in a minute or so. Okay, cool. Let me just, sorry folks. This is still having a little bit of an issue, but it's all you have symbols. Just 3 steps. If you follow them diligently, you'll get your solution. That's what most of compiler design is all about, at least for Gate. Is the session, is it stable now? Okay, so I think it is stable now. So in case something breaks, I'll record all these questions. I'll show the question, give some time, record the solution for it, and put it on YouTube by in an hour or two, right? So sorry for that. Again, I had to travel on an emergency to my hometown, and I'm having a little bit of an issue here, and record it. And again,